All right, so Riemann sums is finding the area under the curve with adding up rectangles and stuff. Those of you that have had stuff before, what is that squiggle?
Integral.
Integral. And Felipe, what does integral mean?
Finding the area, like underneath the line.
So finding all the area underneath the line. So we were doing rectangles the other day. The height of the rectangle is f of x, and dx is the width. So here's f of x, there's dx. So it's find the area of the rectangle over and over again over the course of, for this example, 0 to 2. So that notation was needed for the textbook homework, but I'm replacing the textbook homework with Trapezoid Rule, and they might use the notation for the integral as well. So just a heads up. Also, I put some of those irritating, write what this means, what are the units of this problem in context of the problem. I think I took off the ones that were full-on integration that we haven't done yet kind of thing. But if you come across those, just go click next and then get to the ones that make sense. Okay. What's today? Trapezoids. So, given this and what you know about trapezoids, because we did them yesterday, or as a warm-up, what's the area? Find it. Well, I figure out all the people that are absent. You guys get? 11/8. Do you guys agree? Okay. So there is an easier way to slightly, not a lot, but trapezoid formula, add the bases, divide by 2, and multiply by the height. So the half in the formula for the averaging is going to be the same. The height, in this case, these are uniform spaced things. So the area of the whole thing is a half times a half, and this first height once, this middle height was the bottom of the first trapezoid and the top of the second trapezoid, plus this height. So 3 5/2 times a quarter, 11/8. Just a warning, they may not always give you equal steps. So Andy, yesterday in doing the velocity of the car, if there was like too much that was fuzzed out, and we didn't get a reading at 45, instead we got a reading at 48, and we got a reading at 12 instead of 15. So the widths might not always be the same, so you might not always be able to take this factored out. Alana, can you put the laptop away? Thank you. Is our estimate over or under?
Over,
Why?
because there's a bit of that's.
Yeah, what math reason would you be able to put on, for justification on a math test? Concave up? Not increasing, decreasing? I mean, concave up, if I checked this way, okay, does look concave business. And if we were doing something that's concave down, that does appear to have things underneath, yes. So if using trapezoid rule, if I ask you if it's over or under, check concavity. Personally, I don't memorize it, I draw it. But keep in mind, the drawing is not justification on the test, it's like reassurance for you. But I would draw it, be like, oh, the trapezoid is entirely neatly under, okay, so because it's concave down, it's an under approximation. Or because it's concave up, the little bits there, over approximation. All right. What about the rectangles? I mean, clearly, LRAM made, this is an under approximation. And this is over. Is it because of concavity? Sam says no. Well then, Sam, what is it?
Could it be like increasing?
Because it's increasing?
That was part of the reasoning for like the delta net.
It is part of the reason for the delta, yes. Yep. So, if it's on yes?
LRAM is under when the function is increasing and over when it's decreasing, and
Yeah.
vice versa for RRAM.
Yes. So, as reasoning for like mathematical justification, if they say, why do you know that your thing is an under approximation? Oh, well, I was doing left rectangle approximation when it was an increasing function, so that yesterday with the car, those of you that did LRAM, for the first 10 seconds your car went nowhere. 0, because you used the speed of 0 at rest for the first 10 seconds. Those of you that did RRAM, you were like, hey, for the last 10 seconds we were doing 60 miles an hour. So one was a gross underestimation and one is a gross overestimation for that particular example. So if you need justification for rectangles, is the first derivative positive or negative? And don't memorize it, draw it for yourself to be like, the line's going this way, the rectangles are going to come off this direction and either be hanging out under or hanging out over. Cool? Because if it's decreasing, RRAM makes an under approximation. If it's decreasing, you're overestimating your starting point. No, it's fine, it's good all the time. Good? Oh. It's okay. Yes. So homework is off of Delta Math. Awkward picture.
Sure is.
Yeah. What would the area of that trapezoid be if those are my dimensions? If my XY values?
Yep.
Positive or negative 12?
Positive area.
Okay, so if I just did the equation, f of x1 plus f of x0 half times the height, it would give me negative 12, right? And you know what? It's supposed to. Can we have negative area? Does that make any sense? Well, all right. Pre-cal last year doing polars, did you ever have negative radius?
That's a
You
good
did.
question.
You did. Does that actually mean the radius was negative, or what did it actually?
Direction.
Direction. Facing this way, you went backwards. So this negative area isn't really negative area. It's you're accumulating stuff backwards. So if this was velocity, would I be moving right or moving left?
Left.
Left. And how many feet, if this was feet per second or whatever, how many feet did I go left? 12 units. And then here, so I was running away from home for some amount of time, and I accumulated 12 feet in the other direction, another 12 feet in the other direction, another 2 feet, and then I started going forward. And right about here, maybe I finally get back to my starting point and I'm moving forward. If I add all these areas and I'll use the symbol, integrating from A to B, whatever this function is. Evelyn, pick a number.
17.
She says 3. What does that mean?
That the amount of like space or like area he went was 3 feet.
Okay.
I
Yeah.
think the final displacement was 3.
The final displacement was 3? What do you think? So I started somewhere and I went backwards a whole lot, and then I started coming forward and then I stopped. It means the displacement is 3. Like, I ran backwards and then I had to come back all that way, and I only ended up 3 feet in front of wherever I started it. So it's displacement. Would your Fitbit say 3, or would your Fitbit have more distance? It would have more distance. Okay. All right. Just checking. And this, I erased it. Awesome. Go me. And it transitioned over from being positive to negative. It doesn't matter. You can crank right through the formula and say this negative one and that positive one, add them together, divide by 2, and multiply by the dx. And it'll give you this much triangle below, this much triangle above, and it'll give you the actual correct answer. It's okay. Just glide right past it. Okay. Can you guys just try and use the trapezoid rule? You can use your calculator for arithmetic if you'd like. Try the trapezoid rule, 6 equal slices from 0 to 3. And the step under y equals x. Why are the middle ones doubled?
Because you have to like you're taking the sides of the trapezoid like twice for like two different trapezoids, so like you count it twice. Except for that you don't need to for the first one or the last one because you're only calculating one trapezoid's area with that side.
Okay, this height of 0 is, is only on the first one, but this line is the bottom of the first trapezoid and the top of the second, and repetitively until we get to the end. Andy, make sense?
Yep.
Anyone get a number yet?
9.0625.
Evelyn, do you agree?
I might have done it wrong, but I got 9.125.
9.125?
Yeah, I'm gonna double check.
Constantine, you're the tiebreaker, what'd you get?
I did it wrong. I got a number below 9, but that's not possible.
9.125.
Yeah, that's fine.
Francesca, are you agreeing with which one? Or none of them? Okay, it is an over approximation, this is concave after what do you do? Okay, so the Delta Math homework is just to check and make sure that you can actually apply trapezoid rule. And it's not meant to be tedious, but you need to like crank through. The kinds of things that AP asks might be something like this. They'll just give you a table of values and be like, hey, what's the average temperature of the day? So, try this question.
In this case,
Noon.
0.
Temperature at noon. They put N for noon instead of 12 in the table twice. We could have done military time, but some students are like, what do you mean 14? Okay. And then I'll tell you the bad news that came out of first period. What's our dx?
2.
So we get 780? I don't know about you, but if the average temperature was 780, aren't we all boiling?
I'm sure about 9.
So,
Divide that by 12.
write that by 12. Why 12, not 6?
There's 12 different temperatures.
There's 12-hour period, 12 different temperatures. Okay, and we get 65.
Okay, so that wasn't just an average formula.
Okay, so here's the thing. I used to teach Algebra 1. If I asked kids for the average, what they would have done is added up all the numbers, divided by the number of numbers, and been like, here you go, and you get like 64.2. And, you know, swear to you, that seems like a perfectly reasonable way to do this. This one, the calculus method, finding these things, it minimizes the impact of the endpoints, because maybe they're outliers, because in data analysis, usually where you cut things, they are often outliers. Like it's colder in the morning and colder in the evening. Is this better? I'm all about algebra 1, add up the numbers, divide by the number of numbers. But we will get to things where we're gonna ask, what's the average value of the function? If we have the rate of something, maybe this is water leaking out of a tank, and integrating is going to give us how much water left the tank in that amount of time. And if we say, oh, over hours 0 to 6, if you divide by 6, that's how much the average that was leaking per hour, that kind of thing. So I don't especially agree with the method that they're making us use here, but it's a thing. And the thing that came out of first period was, there might be an exit card tomorrow. How do you feel about it? Yeah.
Try.
It's to find areas of rectangles, so arithmetic. You can use the 4 function calculators, but those of you that have been relying on Desmos to do stuff for you, you need to be able to.
Something you can just integrate with the actual calculation.
Your normal calculator, your graphing calculator does too much. So the kind of thing, you might have to do a rectangle method, you might have to do a trapezoid, you might have to tell me if it's an over or under approximation and why. What do you think? Mostly it's to get people before they go to Italy. There's, for some reason, there's 50 kids going and like 25 of them are mine. What the heck? Are any of you going in this class? No? Our tiny class is going to remain as big as it is. Okay. I have 4 missing in one other class and 5 in another. So I have not finished grading the tests, so I really don't want a new stack of papers, but yeah.
So just to like review real quickly for like the rectangles to check, it's you want us like for a justification to say if it's LRAM and the function is increasing, then that's why it's an under approximation. So kind of like that because yeah.
Yeah.
Okay.
So over this interval, the function's increasing the whole time, or f prime is positive the whole time. Okay, if it's positive the whole time, increasing, and I asked you to do RRAM, choosing from the right and then doing the rectangle over, it would be an over approximation. If I said, oh, well, actually, just kidding, I wanted you to do trapezoid rule, ooh, and I won't make it go underneath. Yeah, I can't even draw. But trapezoid rule is based on.
And would you wouldn't make us do the MRAM, right, for any checking?
Made MRAM, like yesterday with the, if I just give you a table and I gave you these numbers, it's really not any different, right? And they've never asked, I've never seen it, and in like looking over 50 plus years of these things, doesn't mean it wasn't in there anywhere, but they don't ask about MRAM if it's an over approximation or under. It goes with concavity, not increasing, decreasing, and it's the opposite of trapezoid rule, and I don't care, I'm not gonna ask. But fighting chance, concavity is the opposite of trapezoid rule. Okay, so exit card tomorrow? Like I need another stack of papers.
Okay.
If I can help you grade the papers.
Yeah, you know,
I'll grade my papers.
multivariable offers every day. They're like, hey,
Why not say yes?
How about this? I'll grade me and Paolo's papers just to take some 2 tests.
I want to grade Matt's paper.
Why don't you let them grade papers?
What?
What's job and jazz?
Oh, shit, we're not gonna do
Multivariable kids. Seem smart.
we going to elementary school.
I'm looking to see an example that would be good to show. Let's go to the Google. Hello. Wow. So used to giving videos. I don't want a video. Still video. Okay, well, let's make a problem. What's our situation? Do we have something adding or something going away?
Adding.
Adding. Every teacher's favorite. At time 0, we had no snow. We have our little noses pressed to the window in 1 hour. How much more snow do we have?
9 inches.
9 inches. This isn't Ithaca. Lived there where that happened. It was challenging. So we have 1/2 inch, and we're watching, and then we have 3 inches, and then we have 3.5 inches, and we go to bed, and in the morning we wake up, and how many more inches? How deep is the snow in the morning? 14. Okay, LREM, RM, which one? Big one. R? So how much snow has fallen? Per hour. So we gotta make sure that we're not double counting. And is RM gonna over or under approximate? Over. Because it's increasing, it's not suddenly disappearing, it's not suddenly melting. And my answer of how much snow fell is dumb, because we already have the answer. 14 inches fell. But,
Assuming that it all melted in between.
yeah. See, this is why I was trying to look one up. My answer is, my question is dumb. Those of you on the internet, is it like incredibly slow? Or is it just me personally? Like today?
Oh, yeah. Are we doing calibrants? That's one, like, if you want
Yeah, and that, Yeah, bad example. Ugh. So here's an example. The kinds of things AP asks, and you guys come back after the test complaining about bananas and plankton and hot potatoes. Because it's like, oh, the amount of plankton swimming around that can be observed through the ozone hole is increasing at amount of, you guys have to calculate using some rectangle approximation method or something, or, oh, bananas are flying off the shelves over COVID at this rate, and you're like, I don't care about the stinking bananas. Did you have the potato problem? What did you have last
I
year?
had a problem about like plankton.
You did have a problem about plankton? Yeah. I don't know. Every year you guys come back like angry about food or something. Anyway, perhaps just try the Delta Math and let me know how it goes.
Is there an exit correction one?
That's the conversation. I don't want one, but I think it is in our best interest to